I would like to introduce our first speaker of the day, Matt Cleary from Enea Consulting. Based in France, he's bringing almost 10 years experience specialized in energy consulting. He's worked with Oliver Wyman in its global energy practice previously. And his specialty is really hydrogen, energy finance, and hard to abate sectors, aviation, shipping, steel. So this is really an interesting point of view, how would I say, a critical point of view on the situation about green hydrogen. And so I'm very pleased to welcome you, Matt, and I look forward to hearing your point of view and your expertise based on the different projects that you've worked on globally.
Thanks very much, John. Thanks for the welcome. And hello, everyone. Great to be here with you today and to have this opportunity to speak to you about what's a very exciting and rapidly evolving market in the hydrogen sector. So I'm Matt Cleary. I'm a manager with Enea Consulting based in Paris, and I lead a lot of the work that we do on hydrogen in Europe. The aim for this short presentation is to give a brief introduction to Enea and the work that we do, as well as share some of our perspectives on the hydrogen market based on our experiences in Europe, some of the lessons that we think can be learned and which we think might be interesting as hydrogen starts to develop in the African context as well. And we'll leave plenty of time for questions at the end, so please do get involved and make it as interactive as possible. All right. So I'll start maybe with just a few words on Enea Consulting. So we're a strategy and financial advisory firm based in Paris, and we work with our clients to accelerate the energy and climate transitions. So we were founded in 2007, and we work with clients across energy, industry, and finance to develop new business models, help position on new technologies, and to help decarbonize their activities. We have a financial advisory practice which provides services for firms looking to raise funds or participate in M&A transactions. And we have advanced analytical capabilities to help our clients solve the most challenging data issues related to energy and climate as well. So today we're about 80 people. We've got a mix of backgrounds, so commercial, technical, financial, which means we can really help our clients across a wide range of different angles. We have our base in Paris, but we have a presence across different markets globally, so Asia, Australia, and now in the UK as well. And we have our capabilities across a wide range of different topics. So different energy and production technologies, so hydrogen, of course, but also closely related technologies and resources such as biogas, bio-LNG, renewable energy, and so on. We also work in infrastructure, in helping clients to reduce their emissions and looking at sustainability and impact more broadly as well. It's also worth noting that we have a long-standing presence in Africa, so we do a lot of work on the continent. So notably through our Energy Access Booster program, which helps to support entrepreneurs working in the field of energy access in Africa and also in Asia. So we've got a long history of working with African companies and helping to develop African energy solutions. Quick word on our client footprint. So we work with energy companies and large industrial companies to help diversify their activities. So looking at new energy technologies, looking at energy transition and the opportunity that that can create from a business perspective, but also looking at a decarbonization angle as well, so helping them to figure out how they can reduce the environmental footprint of their activities, helping them to put in place strategies and solutions which help them to do so. We have close relationships with financial actors, so banks and investment funds, which we think play a critical role in unlocking capital to facilitate the transition. We also work with public actors, helping to define the way that markets are going to work, and we work with startups who are helping to reshape energy markets by introducing new business models and new technologies. And it goes without saying that in the hydrogen space, all of these actors play a role, which is one of the most exciting things about the space. You've got a mix of incumbent energy actors and industrials, and a mix of startups looking to kind of revolutionize the space with new technologies and new models. It's one of the things that's most exciting about hydrogen. So without further ado, maybe I'll just start by giving a couple of perspectives on the market globally, and then I'll go into this idea of the lessons that we can learn from the European experience. So just a quick word on context in the market. So as you'll all be aware, this is a moment of huge excitement and hype in the hydrogen space. So these figures show from the first half of last year only the amount of new projects and investment that was announced by companies and by governments. And you can see the increase is absolutely astronomical in just a few months. And we think it's obviously great, and we welcome the level of ambition that companies and governments are putting forwards on this topic. But we do think it's worth just putting a word of caution alongside that. The low carbon hydrogen sector remains relatively early in its development. And we think there are a few challenges that need to be resolved for it to really scale up and reach maturity. So three of the challenges that we list here. So the first is the fact that hydrogen today, when we talk about it, is by no means a clean energy technology. So a super low share of hydrogen from green sources or from blue sources, as they're called, in the market today. Hydrogen is extremely polluting, responsible for hundreds of million tons of emissions, CO2 emissions each year. And focusing on reducing these emissions, therefore, needs to be a clear priority for the sector. The second issue we would highlight is continued uncertainty around how markets are going to evolve in the future. And one of the ways that manifests itself is through volatility in share prices of companies who are acting in hydrogen. There's a lot of competing technologies and business models and startups looking to break into this space. And I think the volatility which is observed in the prices of those companies reflects the fact that investors aren't sure which technologies or which solutions are going to prevail. So, for example, some of the examples listed on the page here saw growth of 8 to 10 times in 2020, only to fall back by 20, 30, 40% last year. So really kind of quite wild swings occurring. And the final point that we note on this page, the final challenge, is the implications of scaling up the green hydrogen sector for the wider energy landscape. So here in the IEA's net zero emission scenario, they talk about the power demand that would be required to fuel electrolyzers in 2050. And you can see it's almost 20% of global power demand, which is in absolute terms more than the US and China combined use today. So really kind of astronomical levels of demand. And that raises important questions about the cost of that renewable electricity, and also potentially social questions, political questions about where the capacity will sit, how it will take space physically in our countries, and so on and so on. So we obviously welcome the exciting moment that the sector is experiencing today, but we caution that there are still challenges that need to be resolved to get the development of the market over the line. So with that word of context, what I wanted to talk about was some of our experiences on hydrogen from working in the European market, and some of the lessons that we think can be learned from the European experience, which might be relevant as hydrogen develops and scales up in the African context. So 3 points. The first, looking at demand. So hydrogen has a wide range of potential use cases for everything from transport to mobility to power to a bunch of other topics. And our view is that that's great, but we need to try and maintain a sense of realism and pragmatism about the use cases where hydrogen is genuinely the best or most effective and most efficient option, rather than necessarily seeing it as a miracle solution for every scenario. There are some opportunities which we think can develop in the short term, some in the longer term, and some which we think should be deprioritized. So more on that in a minute. Secondly, on supply. So there's a lot of talk in the industry about reducing the production cost of hydrogen, which is clearly very important, but we think it's not the full story because the cost to final consumers includes things like transportation, storage, and distribution. So we need to reflect the full cost of that rather than just the cost of production. And secondly, I know this is a green hydrogen conference, but we think it's also worth talking about the role that blue hydrogen can potentially play in helping to scale up markets in the short term. And finally, a third point about policy. So governments are setting out hugely ambitious targets and investment programs on hydrogen to support the development of the low carbon hydrogen market, and we think is great. But they need to go further, in our view, to help establish the kind of detailed policy frameworks which will support markets to develop further at scale. So I'm going to talk about each of those 3 points in a bit more detail, but the focus is really on demand, supply, and on policy. So on the demand side, so as I mentioned, hydrogen production, requires energy, it requires effort to put into place. And our view is therefore that the usage of hydrogen should focus on the applications where hydrogen is genuinely the best source of the best energy form for consumption, rather than viewing it as a miracle solution in every scenario. So what we're going to lay out on the page is a very illustrative, high-level view of some of the potential use cases of clean hydrogen, and talk about the prioritization that we could give to some of those different groups of use cases. So in Europe, the experience has been so far that a lot of the kind of large scale projects have focused on sectors where hydrogen is already used at scale today. So you can think about refineries, you can think about chemical production, you can think about ammonia production for fertilizers and so on. These are industrial processes where hydrogen basically has no easy replacement, and we're already using, millions, tens of millions of tons of hydrogen every year. So for us, it makes perfect sense to focus on these use cases first, to decarbonize the kind of gray hydrogen that's being used today. Because you already have all of the downstream demand infrastructure and equipment in place, you just need to swap out the production for something that's less polluting. So for us, this makes perfect sense as a kind of starting point for clean hydrogen. And it will be, we think, similar in the African context as well. So there's a few million tons of hydrogen which is produced to produce fertilizer in, for example, Egypt and Nigeria. And we think those are places where it would make sense to start looking at potential first cases for hydrogen on the continent. Over the next few years, there might be additional use cases for hydrogen that start to develop based on specific local context. So it could be in industry. So for example, green steel production, or use in power generation, or use in cement making, industrial heat. It could also be, so in Europe, we're talking about blending hydrogen to the natural gas network. We're talking about some heavy mobility applications. So for example, some of the densest road freight corridors, developing hydrogen filling stations to power trucks along those routes. In the African context, that could be slightly different. So we know that there are projects in the off-road mobility space already, so Anglo-American and the kind of mining truck project that was talked about yesterday, I believe. And you also have companies like HDF, Hydrogène de France, who are looking at hydrogen-based off-grid power solutions, which could also have a role in some African contexts as well. So in the next few years, these are kind of technologies or applications where the technology isn't perhaps perfectly ready today, but we're seeing some first trials, and there could be opportunity to scale up if the kind of business case and the technological case makes sense. Even further out, we might see some kind of the 10-year timeframe, perhaps, we might see some of these kind of large-scale power-to-X type projects. So here we're converting hydrogen into other substances which have useful properties. So you can think about synthetic kerosene in the aviation space, which has very high energy density and is useful for long-distance flights. You can think about converting hydrogen into ammonia or into methanol to power container ships, or for large-scale kind of export of hydrogen. And this last case is clearly one that's been talked about a lot in the African context. So some of the kind of super projects in North Africa or in Namibia, those are projects which could definitely take shape in a few years' time. But we think it will take a bit of time for those technologies to really reach critical scale to support such a business case. And then perhaps most interestingly, we think there are some use cases which it would make sense to deprioritize in a lot of cases. This is going to be context specific, but we think, for example, in light mobility, so passenger cars, it's often going to be the case that battery electric vehicles are going to be more efficient because you're not converting the electricity into hydrogen. They'll need to reconvert it then through a fuel cell back into electricity to power the motor. So in many cases, depending on the range and depending on the particular application, it might be the case that battery electric vehicles are more efficient than hydrogen vehicles, and therefore it's better to save the hydrogen for other kind of more complicated, harder to decarbonize sectors like aviation or shipping, for example. Similarly, for residential heating in the European context, there's some talk about building dedicated, hydrogen distribution networks to take hydrogen to the home, to power hydrogen boilers and so on. Again, we think, heat pumps are likely to work just as well or better in most cases. And again, it would save the investment and the hydrogen production for other uses. And then similarly, for short-term power balancing, grid-scale batteries are likely to do a more efficient job than having hydrogen storage coupled with fuel cells, for example. So it's not to say that these use cases will never develop, but it's more to say that in the kind of immediate kind of 2-year, 5-year, 10-year time horizon, we think there are going to be other cases which develop more quickly and where it makes sense to focus development and business efforts. All of this is very context specific. So there might be certain cases where it makes sense, for example, to have hydrogen being brought into the home. But we think on the whole, the cases towards the left are where investment and effort should be focused in the short or medium term. This also raises an interesting point for project developers. So people who are looking to develop large scale production projects, one of the big challenges that they're facing in Europe at the moment is understanding where the offtake is going to come from. So understanding who's going to offtake the hydrogen, and where that demand is going to come from. And that's going to be the same problem, the same issue, the same challenge in the African context as well. So thinking about where the offtake is going to be, what transport is required to get it there, all of these questions are super important to consider. All right, I'm going to move on to supply. So here there are a couple of points we wanted to make. The first is looking at the overall cost stack rather than just looking at the cost of production. There's a lot of talk within the industry about trying to reach $1 per kilo or $1.50 per kilo of hydrogen produced. And obviously this is super important in terms of bringing costs down for consumers and helping to scale up some of the demand cases that we just saw on the previous page. But we think that sometimes this debate ignores the kind of downstream challenges and costs that are faced in getting that hydrogen to consumers and getting it into in our energy system. And depending on the specific use case, depending on the production case, that can represent this kind of transport, storage, and distribution as part of the value chain can represent quite a significant portion of the cost. And that raises challenges and questions about the way that projects are set up and the way that hydrogen is used. So in Europe, for example, there's a big debate at the moment about whether projects should be so centralized, so large-scale projects with a transportation network which then ships hydrogen around the continent, versus more decentralized projects which are built very close to demand clusters. And this isn't a debate that's at all settled. It comes with it a lot of discussions about the best way of transporting and storing hydrogen. So for example, we look at pipelines versus perhaps trucks versus perhaps ships for longer distances. And then within Europe, there's a big debate about how to reuse or the role that natural gas transportation infrastructure can play as well. So should we blend hydrogen into the natural gas network? Should we retrofit the natural gas network to transport hydrogen? Or should we develop dedicated hydrogen pipelines that can transport hydrogen on their own? So there's a big debate about that and about the specific carrier of hydrogen as well. So gaseous or liquid versus ammonia, all of these debates are yet to be resolved. In the African context, it will be similar. So needing to think very carefully about the way the projects are set up, where the demand is coming from, as I just mentioned on the previous page, and understanding how the hydrogen will be transported to those demand use cases. The equation will be different again in Africa because, for example, there is obviously much less gas transportation infrastructure than in parts of Europe. So there's not the question about retrofitting and so on. It'll be more about, is there the opportunity? Does it make economic sense to develop dedicated hydrogen transportation, for example? Second point I wanted to make, and I alluded to it earlier on, this is obviously a green hydrogen conference, but just a word on the role that blue hydrogen might be able to play. So the graph shows in the IEA's net zero emission scenario in 2050, the sources of hydrogen supply. And so you can see almost 40% is coming from fossil with CCUS, so kind of what we would call blue hydrogen. And we would highlight that in the short term, CCUS technology can play an important role in helping to decarbonize the tens of millions of tons of hydrogen production that exists today. So already in the short term, before we talk about gigawatt scale electrolyzers, starting to reduce the emissions from the hydrogen that's already being produced. And helping to scale up the low carbon hydrogen sector that will enable projects to develop and demand sources to develop as well. And in the longer term, we may also see a role for blue hydrogen in some specific geographies where natural gas is very abundant and low cost, so the US or the Middle East, for example. And it may also help, blue hydrogen may also help to reduce the power demand for electrolysis as well, which, as we talked about at the start, could represent up to 20% of total demand. So it can be very, very consequential. So obviously, we're strong advocates of green hydrogen, but we do think it's important to have a pragmatic point of view on the role that blue hydrogen can play in some circumstances. It might be the case in Africa as well for gas producing or coal producing countries too. Okay, final word on policy then. So as I talked about at the start, so governments are putting in place hugely ambitious targets and investment programs to support the development of clean hydrogen, which we obviously think is great. So the EU wants to have 40 gigawatts of capacity by 2030. Germany is the new coalition government that's just doubled its target by 2030. And it's the same thing in certain African markets as well. So Egypt and Morocco on this page have set out ambitious targets for the coming decade or decades as well. However, what we would observe from the experience in Europe is that there's a gap between the ambition that's stated by policymakers and the reality on the ground, where investors are delaying final investment decisions because they don't have clarity on the regulatory framework that's going to sit behind that to deliver those targets. And there's a range of different levers and enabling measures that need to be put in place. So this is a paper that was written by Irina and the World Economic Forum in November, and it gives an example of what they call enabling measures, which cover supply and demand, so cascading down the macro targets that have been set into specific targets by industry or specific hydrogen clusters. It includes financial support mechanisms, so things like contracts for difference on carbon, things like infrastructure capacity payments. It also talks about non-financial measures like standards, so standards on safety, standards on transportation, standards on carbon intensity, so defining what is clean hydrogen. And it talks about coordination across the supply chain as well, so setting production targets for things like electrolyzers, coordinating R&D spend, coordinating workforce strategy, and so on. So there's really a lot of different factors that need to be put in place. And it's not to say that there won't be projects and there won't be growth without all of these things being implemented, but to reach the kind of targets in the kind of time frame that governments have set out, we think it's really important that the next level of detail is provided, which will allow investors to kind of grow in confidence and take the decisions that are required. All right, I'm going to stop. Just a final word on the types of projects that we've been doing in the space, just to give a bit more of a tangible flavor of some of the work that we're doing. So as I said at the start, we work with our clients on the strategic and operational challenges they face. So a couple of examples on the page on the strategy side here. So helping a hydrogen project developer in Europe to define their strategy across different markets. This is very much linked to what I was saying before about finding the use cases which make sense in a particular local context. So here we went through mobility and industry applications to figure out, okay, in a specific country, in a specific region, what are the applications which can make sense, helping to define and prioritize that. We did a project for an infrastructure investment fund recently looking at the role of hydrogen in aviation. Here again, understanding the role that hydrogen can play and its limitations. So where biofuels, for example, might be more attractive, and understanding the investment in infrastructure, the implications that are required on that front, helping to understand some of the startups who are developing new technologies which might help to revolutionize that space. And then more operationally, we also help our clients to develop projects in the space. So this is an example from a logistics provider in Europe, where we help them to develop a green hydrogen project, including selecting the site, including doing the pre-feasibility study, and including helping them get it through their investment committee. So we're very comfortable working across both the strategic side, but also on the more operational side. I've talked for quite a long time, so very happy to have questions if there are any from the group before we close. Thank you very much.
Mats, yes, there were many comments about the great presentation, excellent points being made, and we do indeed have a few questions already, and I'm sure as we will speak, there will be more questions. Let's start with a question from Michael. Your estimates, out of the 150 announced projects, how many will be realized?
Yes, that's a very good question, which I'm not going to answer directly. I think it's very much linked to the point I was making at the end, so about the need for more clarity on the regulatory framework and the detailed kind of structure in which these projects will be operating. So I think, even this year, we're expecting in the UK and in Germany and some of the key European markets, more clarity on things like contracts for difference and things like carbon thresholds and so on, which will really give investors some more clarity and help them to make those final investment decisions. So it won't be all of the 130, but hopefully it will be a decent proportion as investors get more certainty on how the market will play out.
I have a question from Maria. It's a rather long question, but I will read it out if you don't mind, because it's an interesting logic. How do you address the question of cost in the case of blue hydrogen? Aside from the issues related to commercializing CCS, the current cost of gas as a feedstock basically eliminates the case for blue hydrogen. At least that's what Maria says. With the extreme gas price volatility we've been seeing globally, and which is likely to continue, this price of gas keeps increasing. So you said you were in favor of green hydrogen, but you're not excluding blue hydrogen at all. How do you address that specific point?
I think our view is that, so in the short term, this view of it being an absolute must that we have to try and decarbonize the production of hydrogen today, we think that's absolutely critical. So although the gas price is high, there's still tens of million tons of hydrogen that we produce this year, using gas or using even coal in some cases, and seeing CCUS as a way of reducing the emissions from that activity in the immediate term is absolutely critical from our perspective. Longer term, you're right, the current crisis and the impact on gas prices obviously does damage the case for blue or even grey hydrogen, which is obviously great for electrolysis and the renewable power sector. But we still think that in certain geographical contexts, so the US and the Middle East, for example, where natural gas is so abundant and perhaps might be a bit more disconnected or insulated from the effects of the crisis in Russia, we think there could still be a role longer term for blue hydrogen. But clearly it will depend on how it plays out. Obviously, if the crisis currently accelerates electrolysis and the growth of green hydrogen, then all the better from our perspective.
And maybe a last question. We had a few listeners from Nigeria yesterday. We had also a presentation dedicated to a project in Nigeria. I would actually like to ask you, within the existing users of hydrogen, what would be your recommendation for them to consider the switch to green hydrogen? Is there any specific resource they would need to look into, any specific advice they can get from somewhere? What would you recommend them to do?
So the thing that we always say is to look at, so when you're considering a hydrogen project, to look at all of the different elements that are required both on the supply side, but then also on the demand side. So if you're a fertilizer producer today, you've probably already got all of the downstream infrastructure in place to convert the hydrogen to ammonia, to convert the ammonia into fertilizer and so on. So for there, you really need to think about the production element. So understanding where your renewable power is going to come from, understanding what size of electrolyzer you would need, understanding all of the different bits of infrastructure that you're going to need to store the hydrogen on site if you've not got it already, and to understand the economics of that solution versus the solution you've got in place today. So it's really about understanding the full kind of project economics and tech stack, and then figuring out if it can make sense for you. And in a lot of cases now, it probably won't necessarily. There's going to need to be a role for government support, both on the kind of structuring side, as I talked about, so the kind of regulatory framework, but also in terms of funding, perhaps to get some of these kind of flagship initial projects off the ground. So understanding what the kind of role of public support can be, or the investment that you're able to achieve from other places as well. It's going to be super important for helping these projects to get off the ground.
I'll take a last question. Really, I have to make a choice because there's several very interesting questions. Question from James with regards to policy. What do you think is the role of government subsidies, government support? Again, there was a little bit of discussion about this yesterday, and it would be interesting to get your point of view on there. Do you think there should be some? Or do you think, on the contrary, let the market play and let the best low-hanging fruits develop by themselves?
First of all, good to hear from James, an old friend. The role of government subsidies, I think, is going to be an important one. I think if you look at the way that renewable power has developed, I think that is perhaps a great illustration of how government support can really help to provide kind of rocket fuel for an industry, really taking it from low capacity, high cost to something that's really at massive scale today and extremely cost competitive. In the hydrogen space, so thinking about things like contracts for difference, which provide some kind of cost parity or provide some kind of incentive for lower carbon hydrogen projects. Those are the sorts of mechanisms we think allow enough support from governments to support these projects in the first place, without necessarily being overly prescriptive on the exact technology or the exact way in which a project needs to be set up. So we think it's about allowing that flexibility between allowing the market to decide whilst providing some certainty for investors and for project developers to get their projects off the ground.
Well, thank you very much, Matt.